memory bus snooping, and Open Debug interface exploits, in IoT devices, a DIY tutorial. Demo using a popular Wi-Fi web camera. This video will demonstrate extracting configuration information from the exposed memory bus in a Wi-Fi camera, and use the extracted username and password to get access to video streaming. Warning: this video is for research and learning purposes only. Please do not misuse the information for unauthorized access. Any attempt to hack a device you do not own or without authorization is illegal. Acknowledgement: the firmware analysis and decryption are based on the TAPO C200 IP camera research project, created by Su. Link available under the video description. The target device we are exploring is a TP-Link TAPO C100 Wi-Fi web camera. The CH341A flash programmer is used to read memory contents from the target device's flash memory. A pair of ESD tweezers is also required. Use the handle of the tweezers as a lever to remove the front panel of the Wi-Fi camera. The mainboard is exposed. Carefully unplug the wires, and release snap fits to pull the circuit board out. There is an SPI flash chip at the back of the camera's mainboard. We are going to read out memory content from it. Now, plug the test clip of the CH341A programmer onto the SPI flash chip. Open the flash programmer software, and select the correct chip model. Before hitting the read button, use the ESD tweezers to short connect the reset pins of the Wi-Fi camera's microcontroller. Otherwise, the communication between the microcontroller and the memory chip will interfere with our readout. The flash memory readout may take several minutes. Please keep the tweezers contact solid. Once the readout is finished, save the binary file somewhere safe. This binary file will be analyzed shortly, to extract sensitive information to allow us to gain access to the Wi-Fi camera. Now we have done with the hardware. Good to have the Wi-Fi camera reassembled and plugged in. The tool bin walk is used to analyze and extract information from the dumped binary file. According to the blog post, the link is available under the video. The device configuration is encrypted with a DES algorithm. The configuration is decrypted on device startup, therefore the encryption key is stored on the device, somewhere inside the dumped memory image. The blog further suggests the DES key is derived from the model number and hardware version. The device used in the blog is TAPO C200 1.0. The Wi-Fi camera we have got is TAPO C100 2.0. Therefore we would like to search for C100 2.0 in the dumped file. There is a string C100 2.0 located at memory address hex 200C0. This should be the key material we are looking for. The blog author extracted the key derivation algorithm from the firmware. As a DIY tutorial, we do not dig it in depth. Interested audience may refer to the blog, link provided below the video. Run the data derivation algorithm in an online compiling website, replace the device model number to match our device. Now we got an 8-byte ASCII string, which is the DES decryption key for our Wi-Fi camera. This 8-byte ASCII string needs to be converted into hex bytes to suit the decryption tool. Now we use the OpenSSL, together with the key derived before, to decrypt the binary flash image. If the DES key is correct, binwalk should be able to detect the partition encrypted before. The configuration file is now in plain text. We can try to search for passwords. We can see the root account admin is here. However, instead of storing the password, the Wi-Fi camera stores a hash value. The 128-bit space 16 suggested as might be an MD5 hash value. As a hash function, it is theoretically impossible to calculate the password from the MD5 value. But we can try the rainbow table, a pre-calculated password to hash value mapping dictionary. No luck. The password is obviously not in the dictionary that this website has. Let's try the shared password of the admin account. We still have no luck with this password. Apart from the admin account, this Wi-Fi camera also has a third-party account, allowing the third-party devices to get connected with the camera. For example, a network video recorder. This time we successfully reversed the password from the MD5 hash value, otherwise, you would not be able to see this video. Let's quickly record down this password. We can see this Wi-Fi camera supports real-time video streaming protocol RTSP at port 554. So, let's exploit the extracted password to get access to the video streaming. To get access to the video streaming, we need the camera's IP address. It is static and available in the configuration file. Now, open up a video player software that supports RTSP, such as the VLC Media Player. Copy the link we built into the VLC Media Player and input the account name and the password we extracted from device memory. And that's it, the video streaming is connected. In summary, in this video, we demonstrated extracting sensitive information from IoT devices by exploiting an exposed memory bus using tools below $15.